You see, Mumbai monsoons are the best time for vacation. I can just lie on my bed and stay snuggled up in my blankets. I can read all the books I ever wanted to read. I can watch all the movies that I ever wanted to watch. And I can read up all the WhatsApp messages that I've kept pending on my phone since the past few weeks. Except that I'm an IB student, and now I'm just sitting on my bed filling up college essays and IAs and assignments, projects, whatnot. So in the beginning of this vacation, I received a mail, which was basically the source of this venture. And I've given a TED talk before, nearly a year and a half back after I published my first novel. And I must say that I was particularly thrilled by the fact that this year the TEDx and DAIS will have no theme. You see, when there are no shackles, when there are no chains or restraints, human creativity can just span the cosmos. So, keeping with the spirit of freedom, let's talk about two of the most powerful prongs in the fork of civilization: physics and economics. Two vastly different disciplines, aren't they? One talks about laissez-faire capitalism, while one talks about relativistic mass dilation. One talks about nature, while the other talks about human behavior. One talks about the world of money, whereas the other one talks about, well, everything in this cosmos. But are they truly mutually exclusive? Are they truly irreconcilable? Or are they simply two sides of the same coin? You see, when I was 7 years old, my English teacher told me that I needed to work on my vocabulary, so I got down to work. No reading books, no reading novels, straight up reading the Oxford Dictionary. Yeah, so as I was flipping through the Oxford Dictionary, I was going A for aardvark, B for blasphemous, E for egalitarianism, I for interdisciplinary. It wasn't until now that I finally understood the significance of something that's interdisciplinary. If you love two subjects, then why not study both? Let me tell you something interesting about physics. If a car is traveling in 20 kilometers per hour towards another car coming towards it at 30 kilometers per hour, then their relative velocity is 50 kilometers per hour, period. No frills to that. Except that things aren't as concrete and as simple as that anymore. You see, scientists started to discover anomalies in the motion of the particles of gas, what we know as Brownian motion. And they discovered that they could not really predict the path or the behavior of one single particle, but grouped thousands of these together into a fluid, and they could pretty lucidly calculate how this gas or fluid will react under specific physical conditions. It's the same with economics. Economics does not really predict how an individual will react, but on the contrary, group thousands of these people together into a nation or a country, and economists can pretty accurately determine which way the public will sway if the government, let's say, launches a new bill, or if the inflation rates rise, if currency depreciates, so on and so forth. So similarities like these in physics and economics abound, and not only such similarities but also mathematical symmetries and similarities. You see, in Newtonian gravitation, the force of attraction between two bodies is calculated by the equation F equals G times m1 m2 by r square, where F is the force of gravitation, G is the gravitational constant, m and m2 are the mass of the two bodies, and r is the distance between the two bodies. However, in economics, for the gravitational model of international trade, now obviously this sounds like a very bizarre relationship, but bear with me. In economics, the gravitational model for international trade uses this same equation in order to calculate trade flow, which is governed by the equation F equals G times m1 m2 by d, where m1 and m2 are the GDPs of the respective countries, G is simply a constant, and d is the distance in between the two countries. Now this equation is extremely important, not only because of its symbolic value of the relationship between physics and economics, but also because it tells economists many important factors about international trade, how similar currencies, or how similar cultures or how similar colonial histories may affect the trade flow in between two countries. You see, physics has come a long way since when it was first conceived by mankind, and quant analysis finds widespread application in physics nowadays. Stochastic processes and Monte Carlo simulations are used by physicists in order to determine and predict the outcome of a particular physical system under specific physical conditions with respect to one or more random variables. And these same methods are also used in economics, in actuarial science, in insurance, and many other social sciences as well, because they are human sciences, and it follows obviously that they're not exact sciences. So the number of variables that they need to consider is humongous and almost unimaginable. So when two disciplines come down to the same level of development, such that the mathematical language that they employ becomes strikingly similar, then the only difference that exists in between them is simply in their essence. So, known to very few, these two powerful swords have already been welded into one. You see, in 1995 in Kolkata, in a conference for statistical physics, Professor H. Eugene Stanley coined the word Econophysics, and for good reason. In 1998, soon afterwards, the first conference for Econophysics was held in Budapest, Hungary. Now you must be wondering that how did two disciplines so vastly different suddenly come together and create an offspring? If you consider disciplines like biochemistry or biophysics, then two disciplines have taken decades, if not less, in order to grow together, converge, and finally come to fruition. You see, this accelerated development was primarily possible because of the vast amount of data that financial analysts and economic analysts finally found in their plate. They felt inundated by this data and were desperately searching for different methods and techniques in order to manipulate this data and predict new outcomes or find new correlations. Fortunate for them, they found that these techniques and devices already existed in the realm of physics. And sooner than you could blink an eye, physicists were already writing papers and publishing papers on how to solve stock market issues and financial issues using physical equations. So the point that I'm trying to make over here is that deep down in their essence, in their raw core, these two disciplines are extremely similar. And one explains the behavior of humans while the other explains the behavior of physical objects. Together, these two pillars of civilization do converge, and that is the crux of econophysics. Thank you.